Hi everyone, Assalamualaikum. In this video, we will continue with useful and related integration formulas involving integration by partial fractions. Okay. From the previous video, we have discussed integration of ax plus b to the power of n dx. Okay, when n not equals to -1. After we integrate ax plus b to the power of n, the answer equals to ax plus b to the power of n plus 1 over a, n plus 1 plus c. Over a here, we also can write times 1 over 8. Okay? Alright, in this video, we will continue with formula integration of ax plus b to the power of n dx when n equals to -1. Okay? The answer equals to 1 over a ln modulus ax plus b plus c. Okay? This is useful formula for denominator with distinct linear factors in partial fraction. Right? Bracket to the power of -1, we also can write 1 over the function in bracket. Okay? Using the properties of indices. Okay? In this video, we are going to discuss the example using this formula. Alright? Let me look at example 2a. Let's say we want to integrate 1 over 2x plus 1 dx. We also can write 1 over 2x plus 1 equals to 2x plus 1 to the power of -1. Okay? And from here, we have n equals to -1. Okay? We refer from table of integral in appendix, formula number 1. If we integrate ax plus b to the power of n dx, when n equals to -1, the answer equals to 1 over a ln modulus ax plus b plus c. Right? So from this formula, we also can write integration of ax plus b to the power of -1. We replace n equals to -1. And then dx equals to 1 over a ln modulus ax plus b plus c. Alright? Using this formula, after we integrate, we have 1 over 2. Since we have 1 over a here, a means coefficient of x. So we can write 1 over 2. And after we integrate, no more integration sign. Okay, after 1 over a, and then we have ln modulus ax plus b means modulus 2x plus 1 and then plus c. Okay, this is the final answer when we integrate this function using this formula. Right? We put a modulus sign because ln negative is undefined. So to avoid error, we use modulus sign for ln function. Right? If we don't want to use this formula, we also can integrate using u substitution. Okay? Using u substitution, first we can write integration of 1 over 2x plus 1 dx equals to integration of 2x plus 1 to the power of -1 dx. Since we cannot expand bracket to the power of -1, so we can integrate using u substitution. Okay? So now we let u equals to the function in bracket, which is 2x plus 1. And every time when we integrate using u substitution, we will have derivative part and integration part. Okay? After we define u equals to 2x plus 1, we need to find du over dx. Okay? When we differentiate, the answer equals to 2. And after that, we need to write dx as a subject. After we cross multiply, so we can write dx equals to du over 2. And after that, we substitute back into this function. Okay, so now we have integration of, we replace 2x plus 1 equals to u, and then we still have to the power of -1, and we replace dx equals to du over 2. Okay, over 2 here is a constant, so we can move out constant over 2. Means we move out 1 over 2. Okay? And then we have integration of u to the power of -1 du. So now we have term containing u and du, no more variable x. So from here, we can integrate with respect to u, right? And then we can write 1 over 2 integration of, okay, when n equals to -1, we cannot integrate using power rule. But we need to write u to the power of -1 equals to 1 over u. And then du. So from here, we can refer basic formula. If we integrate 1 over x dx, the answer equals to ln x plus c. So when we integrate 1 over u du, the answer equals to ln u plus c. Okay? And we still have constant half in front. And after we integrate, no more integration sign. Okay? And then every time when we integrate using u substitution, the last step, we need to replace u in terms of x. So the final answer equals to half ln, we replace u equals to 2x plus 1 and then plus c. Right? This is the final answer when we integrate using u substitution. When we compare to the final answer, when we integrate using this formula, the answers are equal. Right? You got it? Alright, now we look at example 2b. If we want to integrate 2 over 2 minus 3x dx, first, we can move out constant 2 outside integration sign. And then we have -3 plus 2, 2 minus 3x equals to -3x plus 2. And then bracket to the power of -1 using the properties of indices. Okay, from here, our n equals to -1. Okay, alright, from table of integral in appendix, if we want to integrate ax plus b to the power of n dx, when n equals to -1, the answer equals to 1 over a ln modulus ax plus b plus c. Okay? Or we can write integration of ax plus b to the power of -1. We replace n equals to -1. And then dx equals to 1 over a ln modulus ax plus b plus c. Alright? So using this formula, we can integrate this function. Okay? After we integrate, we still have constant 2 in front. And then no more integration sign. And after we integrate linear to the power of -1, the answer equals to 1 over a. A here means coefficient of x. So we can write 1 over -3, since the coefficient of x here equals to -3. And then times ln modulus ax plus b, means modulus -3x plus 2 or 2x minus 3. Okay, and then modulus here plus c. Okay, after we simplify, we get -2 over 3 ln modulus 2 minus 3x plus c. Alright, we put modulus sign for ln function. Okay, since ln negative is undefined. Okay, or we can integrate using u substitution. Okay, alright, so to integrate 2 over 2 minus 3x dx, first we move out constant 2 and then integration of 2 minus 3x to the power of -1 dx. Okay, since we cannot expand bracket to the power of -1, so we can integrate using u substitution. Alright, so our u equals to 2 minus 3x. And every time when we integrate using u substitution, we have derivative part and integration part. From derivative part here, we need to differentiate. Okay, so when we differentiate u with respect to x, we get du over dx equals to negative 3. And after that, we write dx as a subject. Alright? So our dx equals to du over negative 3 after we cross multiply. Right? And after that, we substitute back into this function. So we have 2 integration of the function in bracket we replace by u, and then dx we replace by du over negative 3. And after that, we can move out denominator negative 3 outside integration sign. So we have negative 2 over 3 outside integration sign, and then u to the power of negative 1 du. Okay? If n equals to negative 1, we cannot integrate using power rule. So what should we do? We need to change using the properties of indices. So we can write 1 over u. So now we have negative 2 over 3, integration of 1 over u du. So from here, we can integrate with respect to u. We can refer from basic formula, integration of 1 over x dx. The answer equals to ln x plus c. So now we have integration of 1 over u du. So the answer equals to ln u plus c. And we still have constant negative 2 over 3 in front here. And after that, we need to replace u in terms of x. So now our u equals to 2 minus 3x. So the final answer equals to negative 2 over 3 ln modulus 2 minus 3x plus c. Okay? When we compare to the final answer, when we integrate using this formula, the answers are equal. Right? And remember, when the answer is ln, we put a modulus sign because ln negative is undefined. Alright? You got it? Up to this point, you can try exercise 2. Okay? Evaluate the following using the above formula and using U substitution. Okay? We have 4 questions here. To check the final answer, you can use symbollab.com. Okay? From menu pad in Symbollab, we can use this symbol to integrate. Right? This button to integrate. Okay? Let's say we try with question number 1. When we integrate 3 over 1 minus 4x dx using symbollab.com, the answer equals to negative 3 over 4 ln modulus 1 minus 4x plus c. Okay, the syntax is like this, right? So you can try symbollab.com to check the final answer for number 2, 3, and 4. Right? Coming up next, more examples using useful integration formulas. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.